Welcome. Thank you for joining us for webinar 4 in a series of 6 webinars to support participants in Samsung's Solve Tomorrow competition. My name is Julie Baker. I'm the Head of Education at Auckland's MOTAT Museum and one of the judges for the Solve Tomorrow competition. And with me is Sarah Washbrooke from TENZ, who is also a competition judge. We'll start with a karakia.
Maori ora ki a mātou, arahina mātou I a mātou mahi, ki mihia he huarahi mō te kaupapa o te mātauranga o Hangarau, a whina atu, a whina mai, te pau e here nei I a mātou, hui e, tae ki e. Today's whakatauki. E orea te tuatara ka putu ki waho. A problem is solved by continuing to find solutions.
We'll start by looking at the junior category, years 7 to 10. This is a reminder of the design thinking process, or a design thinking process, that your students will be working through in this competition. The focus of this webinar is going to be represented by the prototype stage.
So previously in the design process, you've identified a need, you've done some research, you've developed a brief, you've decided to come up with lots of different ideas or potential ideas to solve the problem, or to help the stakeholders that you have decided upon. This next stage is where we really get deep into the development of an idea or a couple of ideas so that you can explore it further. You may need to do lots of different types of testing and trialing. This could be for materials, it could be for how you fix and fasten things together potentially. You may do more sketches to develop the design more. You may do lots of testing. As you can see in this example, we're continuing with our cat feeder idea. And you can see the cats are actually testing and trialing some very quick, simple models that have been made to see whether they are going to be successful before we make the final outcome. The other key aspect of this is always make sure that you have your stakeholders to give you feedback on this part of the process too, and implement that feedback in your thinking. So why is technological modelling important? Well, the key ideas are we have two main types of modelling in the design process. The big aspects that you have the most influence on as a technologist, as a designer, is the functional modelling stage. And that is really the first stage that you go through when you're actually developing an idea. This is where you may make lots of models. It may not be in the material that you want to actually make the final outcome from, but it may be in other materials. So you can test to see whether the idea is actually going to be feasible. Will it work? Because there's no point in continuing with an idea if it's not going to work. So that's the functional modelling stage. As you work through the process and your idea solidifies more, you will find that you will go more into prototyping. And prototyping is where the product or the models that you're making are more realistic. They may use materials that you are actually going to be using, for example. You may focus on not the whole product, but parts of the product, so how something may fasten or how something may hinge and open. And so you're still testing and trialing, but you're actually going more in depth. So it's actually testing the fitness for purpose of the product, and in this stage you can also get much more stakeholder feedback as to whether the outcome that you're developing is going to work and is suitable for that stakeholder.
So just picking up on that question, what is a prototype again? Quite a lot of time there's a confusion about the difference between a model and a prototype, and so just a bit of clarification on that. As Sarah has identified, you start with a concept, and at this stage you've got lots of different ideas and lots of different thoughts, and you are annotating your concept and you're developing it, and you are slowly narrowing in on a one or two potential solutions to the problem that you have identified. And you might decide that you want to develop those solutions a little bit more. And so at this stage you might work on developing a model of one of those solutions. A model is not something that is a working product. It is simply a non-working representation, and you generally use it to explain the product to others. So you can see in the centre there with the Richmond Schools Kitchen Knives Reimagined project, that they've got various different ideas there that they're working on. There's one that looks a little bit like a mezzaluna with a hemispherical blade, and there's others there that look a little bit like a paper towel holder. And on all of these things, they're not functioning products, they're just a representation of that product that helps explain the ideas to others. You'll be going out to your stakeholders and you'll be showing them to people and saying, this is what I'm thinking of doing, and you'll be getting their feedback, and then you'll come back with their feedback, and that might help you eliminate some of those ideas and decide to focus on something else that you want to develop more fully. And at that stage you might decide to go on to create a prototype of that idea. When you're developing a prototype, you're looking at something that is a functioning product, and you're developing it in such a way to detect flaws and problems. So you have something that is full size, you have something that is designed to be used, you have something that is made out of materials that are going to be suitable for the final product. And in this way you can realistically get your stakeholders to give you feedback that will help you refine that final product as well. Here's some examples of stakeholders and design iterations. Mount Richmond Special Schools Kitchen Tools Reimagined. You can see there that they have a group of people who are using their prototype and doing their testing. And they're doing it in a real way. It's in situ, if you like. So they're actually using the knife to cut the food. The stakeholders that they're using are representative of the user group that they are targeting the product on. So it's a very realistic way of getting good feedback about how useful that product, how functional that product actually is. What are the judges looking for in this category? So we are at this stage looking at the work you do in prototyping and development pops up in the relevance and process criteria. In relevance, we look at your process for evidence of design iterations and for improvements arising from testing. And we look for evidence of your process. So have you done some scientific testing? Have you got some elements of iterative design thinking in your process? And have you shown that in your presentation to us? And we also look to see that you have had some evidence of feasibility consideration. So you've looked at the product and you're making some decisions about whether it's actually feasible in its current form or whether it needs to change to make it a more feasible end outcome. There are a lot of resources available to help you in your project on the Samsung Solve for Tomorrow website, and there is a link here in this presentation that you can use to get to that page. The item which is particularly useful for you when you're developing your prototype is how to develop an idea.
So let's explore the senior category now, and we'll go in a little bit deeper into this aspect of developing an idea. So how are technological and scientific processes used to develop the outcome? As part of the submission for the competition, you need to make sure that you have really clearly shown us the process or processes that you have gone through. You may go through more than one process. We obviously focus on the design thinking model, as you've seen highlighted in previous sections of this webinar. But there may be more processes that you connect to, especially as you have a STEM focus. You may actually go into things like scientific experimentation. You may need to test and trial the materials that you're potentially considering using, for example. And you can document that, making sure that obviously the ideas and the analysis of the results come through and are utilised in your design thinking process. There are also other processes that you may use. Remembering that the design process isn't linear, it may go all over the place. You may need to go back to the beginning and do more research in the development stage, and that makes the process iterative. And that's where you have to keep continuously going back to your stakeholder and getting feedback at all stages of the process. Obviously, you'll be using your brain to do lots of thinking and problem solving. Now, we're not with you whilst you're there doing that. So if you can showcase to us how you are thinking and how things are changing, then it will help us when we're actually looking at your projects too.
So some examples of development in previously submitted entries. You can see the Mount Richmond Special School Kitchen Tools Reimagined project. They are working with various ideas. They've got some models there that they have presented. But what's interesting on the slide is the words in the bottom left-hand corner of it, testing and feedback on early designs. So they were looking at those models and they were trialling them a little bit, and they were making decisions about, actually the rocking knife is a bit hard to control with one hand, and the pounder had limited applications, and the chopping board with the knife groove was going to be hard to clean. So making decisions about their ideas and using them to move their ideas along and develop their solutions a bit more. You can see in the bottom there, Harrison Maxwell's Beautify the Berms project. This is just a really simple little list of the things he's decided that his solution has to have, the criteria, if you like, for his solution. He was looking at replacing grass berms with some more attractive foliage, and it needed to be something that was going to be durable and hard wearing. It needed to be low maintenance and didn't need to be mowed. It was something that didn't grow too tall, so it didn't restrict roadside visibility, etc., etc. And he listed all of those. So we had that evidence that we knew he had all of those thoughts and all of those considerations, and that he was taking those things through into his final solution. And then the last example there is Brooklyn John's, his Nighttime Hero project, which was designed to retain a child's cuddly toy close by them throughout the night. There are 2 slides there, and it's a very clear illustration of how he moved from prototype 1 through to prototype 2. And he has used a coding process where anything in red needs to be developed further, anything in orange is sort of a work in progress, and anything in green has been resolved. And you can see as he went from prototype 1 to prototype 2 that the amount of green things that were solved increased. And so he had worked on that prototype and had changed it and made it into a more fit for purpose solution in the second stage.
So where does developing an idea fit in on the score sheet for the senior category? Well, a lot of it will actually come under the process side of things. So if we're looking at the question, how a technological and scientific process is used to develop the outcome, it comes into that space there. You will also find that parts of this will go through the rubric as well, especially with stakeholder engagement and with the considering with the feasibility of the actual outcome. But essentially, we focus on the actual process itself through the development side of things. This slideshow is available for you to look at again and to use in your own spaces. You can go through the bit.ly link, which is at the top there, or you can scan the QR code to gain access to this slideshow. The webinar has been recorded and it's always available for you through Samsung Solve for Tomorrow website and the TENZ YouTube channel. We'll finish with our karakia. Kia mato katoa. Kua motu mato ia matu mahi, ia matu kopapa hoki. Arahina mato, ki kaue mato ia mato haipapa. Kia whakatapua mato ki nau kopapa me nā mea e whakapono. Manakitia mai mato. Kia ora.